In 1968, Ford built the best cylinder head they'd ever designed. Then they put it on an engine that couldn't keep its oil pressure up, ran hot at idle, and cracked its own block if you bored it 30 thousandths too far. The 351 Cleveland should have been the only small block V8 that mattered. Instead, Ford killed it in 5 years. Here's the thing about the Cleveland. It wasn't some side project. It wasn't a parts bin special cobbled together on a Friday afternoon. This engine was supposed to be the future. Ford's master plan in the mid-1960s was to simplify everything. Too many engine families, too many parts, too much complexity. The idea was to get down to just 2 V8 platforms. One big block, one small block. The big block became the 385 series, the 429 and 460. The small block was internally designated the 335 series, named for its original planned displacement of 335 cubic inches. That displacement never actually made it to production, but the name stuck. Bill Gay was the chief engineer in charge of the project. He'd been an executive engineer at Ford since the early 1960s and had already overseen the enlargement of the 302 into the 351 Windsor. That project took about 9 months. The 335 series was supposed to be more ambitious. A clean sheet approach to a mid-displacement V8 that could replace multiple engine families and scale from economy applications to full race duty. Gay brought in George Stirratt as assistant chief engineer, who in turn recruited a third engineer named Joe Makura. And right there, in the first months of development, the seeds of the Cleveland's greatest strength and its most frustrating weakness were planted at the same time. Because Stirratt and Makura couldn't agree on the cylinder heads. Stirratt wanted to play it safe. Bigger ports and valves than the Windsor, sure, but nothing radical. Conventional layout, proven approach. He'd worked on the Windsor's development and saw no reason to reinvent things that already worked well. Makura had a different idea entirely. He wanted to cant the valves, splay the push rods apart, and open up the intake ports to something approaching big block territory. The experience and knowledge Ford had acquired during airflow studies for their Indianapolis and Le Mans racing engines would go directly into a production cylinder head. 2 completely different designs were built and tested. They were called the 335S and the 335M. Stirratt's conservative head versus Makura's aggressive canted valve design. Ford's sales and marketing team picked Makura's head. They called it more innovative, more exciting, and technically, they were right. It was innovative. It was also going to cause problems that nobody saw coming for about 40 years. There's another piece of the story here that almost nobody talks about. Around the same time, Ford's president Seaman Bunky Knudsen, who'd come over from General Motors, asked racing legend Smokey Yunick to help develop an engine for Indianapolis competition. Yunick had a long history with GM, including input on Chevrolet's Mark IV big block. The prototype Indy engine he worked on with Ford was based on early 351 Cleveland castings. It had a skirtless block, the same bore spacing as the Windsor small block, and cylinder heads with ports even larger than the production 4-barrel castings. The push rods crisscrossed over one another to make room for intake ports that were borderline absurd in size. It was the Cleveland concept pushed to its absolute extreme. When Henry Ford II fired Knudsen in 1969 for, as the official explanation went, failure to adapt to the Ford culture, the Indy Cleveland project died with him. The production engine was the compromise version. Let that sink in. We dig into stories like this every week. The engineering, the people, the decisions that looked brilliant on paper and fell apart in the real world. If you're not subscribed yet, this would be a good time. Now, back to Cleveland. So Ford had this ambitious new cylinder head design, but before the 351 Cleveland even hit production, the heads proved their worth in an emergency. In 1968, Ford was getting embarrassed in the SCCA Trans Am series. They'd built a special racing engine called the Tunnel Port 302, and it was a catastrophe. The thing didn't make peak horsepower until 8,000 RPM. Connecting rods snapped, blocks cracked. Racers like Parnelli Jones and George Falmer were scattering tunnel port parts across every track in America. The Chevrolet Camaro Z28 was winning races Ford should have owned. Bill Barr, another Ford engineer who'd spent years on the FE Big Block program, knew about the 335-cylinder heads being developed for the upcoming Cleveland engine. Same bore spacing as the Windsor small block. Same head bolt pattern. In theory, you could bolt them onto a 302 block with the right pistons. So that's exactly what he did. The result was the Boss 302, Cleveland heads on a Windsor block, and it worked. Ford won the 1970 Trans Am Manufacturers' Championship with an engine that was basically a preview of the Cleveland's potential. The heads could breathe. They could rev. They made power across a range that the tunnel port could only dream about. This should have been the beginning of something legendary. The full Cleveland engine, the 351C, hit production in late 1969 for the 1970 model year. And on paper, it was everything Ford promised. The four-barrel version had intake valves measuring 2.19 inches. Exhaust valves at 1.71. These were the biggest valves on any midsize V8 in production at the time. The canted valve arrangement, tilted 9.5 degrees from vertical and splayed 4 degrees from the cylinder axis, allowed Ford to fit those oversized valves into a 4-inch bore that would have been physically impossible with a conventional wedge chamber head. The poly-angle combustion chamber was shallow and efficient, promoting fast flame travel and clean combustion. Ford's own testing in the early 1960s had shown that this configuration produced the best average torque and horsepower across the widest range of engine speeds compared to any other cylinder head design they'd tested. The engine also had features designed specifically with manufacturing in mind. Coolant was routed through the block first, then to the heads, which meant the intake manifold ran dry. No coolant passages through the intake, fewer gasket surfaces, fewer potential leak points. The front of the block was extended to include an integrated timing chain housing covered with a flat steel plate that sealed better than a traditional stamped cover. These were smart engineering decisions. They were also the first signs that the Cleveland was becoming something bigger, heavier, and more complex than the Windsor it was supposed to complement. Now, the 351 Cleveland came in two flavors from the start. The two-barrel H code was the bread-and-butter version, open combustion chambers, smaller valves at 2.04 intake and 1.65 exhaust, and ports sized for low RPM torque. This was the engine for Torinos and Montegos and family sedans. It made around 250 horsepower and delivered decent fuel economy for the era. Most 351 Clevelands ever built were H codes. Nobody writes songs about them. The four-barrel M code was the one that made people pay attention. Closed quench combustion chambers, those massive canted valves, ports large enough to see daylight through. In 1970, it was rated at 300 horsepower with a 10.7-to-1 compression ratio. It was the engine Ford dropped into the Mach 1 Mustang, the Mercury Cougar, and the car that would cement the Cleveland's international reputation, the De Tomaso Pantera. The Pantera deserves its own moment here. Alejandro De Tomaso, an Argentine-born racing driver turned Italian carmaker, had partnered with Ford to build a mid-engine supercar that could challenge Ferrari at a fraction of the price. Ford owned 84% of De Tomaso's company and wanted a weapon to sell through Lincoln Mercury dealerships. The idea was genuinely radical. An Italian-designed, American-powered supercar available at your local Ford dealer. The 351 Cleveland 4-barrel was chosen specifically for its high-revving character and its ability to make real power in a compact package. In the Pantera, it made 330 horsepower, propelled the car from 0 to 60 in 5.5 seconds, and through the quarter mile in 14 seconds flat. Car and Driver tested one in August of 1971. For a mid-engine Italian exotic with an American V8, it was remarkably civilized on the street and absolutely savage on the track. The ZF 5-speed transaxle, independent suspension, and four-wheel disc brakes gave it handling that most American muscle cars couldn't touch. Ford sold around 5,500 Panteras in the United States between 1971 and 1975. Every single one had a Ford part number on every piece, right down to the 5/8-inch oil drain bolt. It was about as Italian as a cheeseburger, but nobody cared because it looked like $1,000,000 and drove like nothing else in a Ford showroom. But the Cleveland's finest hour came in 1971 with the Boss 351 Mustang. This was the R-code engine, and Ford threw everything at it. 4-bolt main bearing caps, forged aluminum pistons, shot-peened and magna-fluxed connecting rods, a solid lifter camshaft with nearly 550 thousandths of an inch of lift, an aluminum intake manifold topped with a 750 cubic feet per minute spread-bore carburetor. Ram air induction, dual-point ignition. Compression was 11.1 to 1. The factory rated it at 330 horsepower at 5,400 RPM and 370 pound-feet of torque at 4,000. They were lying, obviously. Hot Rod Magazine built one to exact factory specifications in 2010. It made 383 horsepower at 6,100 RPM. Ford had underrated the engine by over 50 horses. In a Motor Trend comparison test in January of 1971, the Boss 351 ran 13.80 in the quarter mile at 104 miles per hour. The 429 Cobra Jet Mach 1, the engine everyone assumed was the faster car, ran 14.61 at 96. The little 351 had beaten Ford's own big block by nearly a full second. So here was the greatest mid-displacement performance V8 Ford had ever built, competitive with any engine in the industry, proven on the street, proven on the track, proven in an Italian supercar, and Ford made exactly 1,806 Boss 351s. Then they stopped. The timing was brutal. In late 1970, Ford officially pulled out of most forms of organized racing. The Boss 351 had been designed partly to homologate a Trans Am racing Mustang. That program was now dead. The car it was strapped to, the 1971 Mustang, had ballooned into the biggest, heaviest Mustang ever built, gaining 100 pounds over the previous year. From the driver's seat, you could barely see over the hood. Motor Trend's editors, after testing 3 1971 Mustangs, including the Boss, said their favorite was the base model with the 302 two-barrel. But it wasn't just market taste that killed the Cleveland's performance potential. It was chemistry and politics and timing. The federal government was tightening emission standards, and the entire American auto industry was scrambling to comply. The Clean Air Act of 1970 set aggressive targets for hydrocarbon and carbon monoxide reduction. Unleaded gasoline was coming, which meant catalytic converters, which meant lower exhaust temperatures, which meant lower compression ratios. For the Cleveland, this was devastating. The closed quench combustion chamber, the very feature that made the 4-barrel head so effective at high compression, became the first casualty. Starting with the Q-code Cobra Jet in late 1971, Ford switched to open chamber heads, dropping compression to 9-to-1. Horsepower fell to 280. By 1972, when Ford switched from gross to net horsepower ratings, the top Cleveland 4-barrel was listed at 266 net horsepower. Still competitive, actually. The 1972 Camaro Z28 made 255, but the trajectory was clear. The engine was being strangled. Then came the 1973 oil crisis. Gas lines around the block. Price spikes. Suddenly, midsize V8s weren't just emissions problems. They were sales problems. The corporate average fuel economy standards that followed in 1975 drove the final nail. Ford needed smaller, lighter, more efficient engines. The Cleveland, with its wider, heavier block and thirsty appetite, was exactly what the new regulations punished. Now here's where the engineering decisions that seemed smart in 1968 started coming back to haunt the Cleveland. Let's talk about the problems, because there were several, and they compounded each other in ways that made the engine increasingly difficult to justify. First, the oiling system. Ford's engineers, focused on cutting manufacturing costs, reduced the Cleveland's main oil gallery from 3 passages, which the Windsor used, down to 2. They also designed the system to prioritize oil flow to the camshaft bearings first, before the crankshaft main bearings. For the low RPM 2-barrel H-code engines puttering around in sedans, this was fine. For the high-performance 4-barrel versions that were designed to rev past 6,000, it was a recipe for bearing failure. At sustained high RPM, the mains weren't getting enough oil. The camshaft was being over-lubricated while the bottom end starved. The lifter bores were generous enough that worn bores leaked significant oil volume at each of the 16 lifter positions, further reducing pressure to the crank. Ford even made special Cleveland-specific lifters with smaller oil holes to control flow, but the fundamental architecture was compromised. Second, the cooling system. The Cleveland's unique coolant routing through the block first rather than the heads required a specific thermostat that blocked a bypass passage when it opened. Use a standard Ford thermostat from a Windsor or any other engine, and the Cleveland would overheat. It wasn't optional. It wasn't a suggestion. It was a hard requirement that confused shade tree mechanics and even some professional shops for decades. Remove the restrictor plate under the thermostat housing, which looks like it's blocking flow. Congratulations, you've just guaranteed overheating. The plate is supposed to be there. It controls flow rate and prevents hot coolant from recirculating through the block instead of routing to the radiator. Third, the block itself. Ford used thin wall casting technology on the Cleveland, which was progressive for weight reduction but created problems for anyone wanting to increase displacement. The factory recommended a maximum overbore of 30 thousandths of an inch. The performance community pushed that to 40 thousandths. Go to 60 thousandths, and you were gambling with cracked cylinder walls. Core shift during casting, a common problem with any iron block but especially pronounced in the Cleveland's thin walls, meant that some blocks came from the factory with cylinder walls as thin as 88 thousandths of an inch in spots. A Boss 351 block that one racer scrapped after persistent overheating and blow-by problems turned out to have catastrophic core shift throughout. The block was essentially defective from birth, and no amount of rebuilding could fix it. Fourth, and this is the one that might matter most, the 4-barrel heads were simply too much for the engine's displacement at street speeds. Those enormous ports that allowed the Cleveland to breathe at 6,000 revolutions per minute were liabilities at 2,000. Air velocity through the port dropped. The fuel-air mixture fell out of suspension. Low-end torque suffered. The 2-barrel heads actually performed better for street driving because their smaller ports maintained velocity. But Ford couldn't market a performance engine and recommend the small port heads. The 4-barrel heads were the whole selling point. So enthusiasts bought 4-barrel Clevelands, bolted them into their Mustangs and Torinos, and wondered why they felt sluggish around town compared to a properly tuned Windsor. And then there was the weight. The Cleveland block, with its wider design, integrated timing cover, and bulkier cylinder heads, weighed around 604 pounds dressed. The Windsor came in at $593. 11 pounds doesn't sound like much until you realize it's all sitting ahead of the front axle. Ford used the same front spring part numbers for the 351 Cleveland as they did for the 390 and 428 FE big blocks. The Windsor used lighter, small block springs. That weight difference affected handling, affected suspension geometry, affected everything a performance car needs to do besides go in a straight line. Ford discontinued the 351 Cleveland in North America after the 1974 model year. 5 production years. But the 335 engine family didn't technically die. Ford kept making the 400 cubic inch version, which used a taller deck block with a longer stroke, and in 1975 introduced the 351M. The M supposedly stood for modified or Michigan, depending on who you asked. Ford never clarified. What it actually was, though, was a 400 block with a shorter crankshaft to bring displacement back down to 351 cubic inches. Same tall deck, same big block bell housing pattern, different motor mounts. It was cheaper to build one block in 2 displacements than maintain a separate Cleveland production line. The 351M was not a performance engine. Nobody pretends it was. Compression ratios floated between 7.74 to 1 and 8.6 to 1 depending on the year. It came only with a 2-barrel carburetor. It was a torque engine for vans and pickups and full-size sedans, and it had its own problems with emissions compliance. Ford had already built Thermactor air injection and exhaust gas recirculation directly into the M-Block's architecture, which made adapting it to the second generation of electronic emissions controls nearly impossible. The oxygen sensor for the feedback fuel system needed to be placed upstream of where the Thermactor air entered the exhaust. On the M-Block, there was no good place to put it. By 1982, both the 351M and the 400 were gone. The entire 335 family was dead. The Windsor, which was supposedly the lesser engine, continued until 1997, 28 years. The aftermarket parts industry followed the Windsor. The racing community followed the aftermarket. And the Cleveland became a cult engine, beloved by those who understood it, frustrated by its problems, and increasingly expensive to build as parts dried up. But the story doesn't end in America. It continues 12,000 miles away, and honestly, this might be the best part. Ford of Australia had started importing Cleveland engines in 1970, and in November of 1971 they began manufacturing them at the Geelong engine plant. The Australians didn't just build the Cleveland, they weaponized it. While Americans were dealing with smog pumps and detuned compression ratios, Australia's emissions regulations were far less restrictive. The Cleveland could still breathe down there, and breathe it did. The Ford Falcon GTHO Phase 3, released in 1971, was a 4-door family sedan turned homologation special. It was built so Ford could go racing at Bathurst, Australia's most important motor race. The engine was a 351 Cleveland officially rated at 300 horsepower. Nobody believed that number. The real output was somewhere between 350 and 380. Ford understated it deliberately to keep insurance companies from losing their minds. The car had a 4-speed top-loader gearbox, a Detroit Locker 9-inch differential, a 36 Imperial gallon fuel tank for endurance racing, and an electronic rev limiter set at 6150 revolutions per minute. Disable the limiter, which everyone did, and the Cleveland would pull past 7,000, even in 4th gear. Alan Moffat drove a Phase 3 to an outright win at the 1971 Bathurst 500, leading from lap 2 and completing the entire 500-mile distance alone. No co-driver, just Moffat and a Cleveland for 5 hours. The Phase 3 dominated Australian touring car racing from 1971 through 1973, winning the 1973 Australian Touring Car Championship. It was touted as the fastest 4-door production car in the world, with Wheels magazine clocking it at 142 miles per hour. Only 300 Phase 3 GTHOs were ever built. Today they sell for over $1 million Australian dollars. One went for $1.15 million at auction in 2021. The Australians also built a unique 302 Cleveland, a short-stroke variant using the 351 block with a 3-inch stroke crankshaft instead of 3.5 inches. This gave it the highest connecting rod-to-stroke ratio in the entire 335 family at 2.01 to 1, making it one of the smoothest revving engines Ford ever produced. It was an economy V8, believe it or not. Only about 10% of Australian Cleveland production was the 302, and they continued manufacturing all of them until 1982, a full 8 years after America quit. When De Tomaso's American supply of Cleveland engines dried up after 1974, they started buying them from Australia. Those Australian-built Clevelands powered Panteras through the mid-1980s. When the Australian supply finally ran out in '86, De Tomaso reluctantly switched to the Windsor. Ford Australia even produced a specially reinforced 351 block for NASCAR, allowing bigger bores, 4-bolt mains, and extra rigidity. Cleveland-derived cylinder heads powered Ford's NASCAR entries from 1972 through 2009, 37 years of racing on a head design that Ford had abandoned for production after just 5. Think about that for a second. The heads were so good that even after the engine itself was dead, nobody could design anything better for circle track racing until Ford finally introduced the FR9 in 2010. The Cleveland's legacy today lives mostly in a hybrid that enthusiasts call the clever. Take a Windsor block, which is lighter, stronger when bored, better oiled, and backed by 40 years of aftermarket development. Then bolt on Cleveland cylinder heads, which still outflow most aftermarket Windsor heads. Drill some cooling passages, fit the right pistons, sort out the intake manifold, and you've got the engine Ford should have built in the first place. 600-plus horsepower on a budget, with none of the Cleveland block's weaknesses and all of the Cleveland head's strengths. There's a certain irony in that. Ford designed one of the greatest cylinder heads in the history of the American 5.8. Then they attached it to a block with a compromised oiling system, a finicky cooling system, thin walls, and a weight penalty. They offered it to the public at the exact moment the government decided high-compression performance engines were no longer acceptable. They pulled out of the racing programs that justified the engine's existence. And when it came time to choose between maintaining 2 engine lines or consolidating around one, they kept the Windsor, the cheaper one, the simpler one, the one that wasn't designed for racing. The Cleveland was built for a world that was already ending by the time it arrived. It was a racing engine born into the emissions era, a high RPM screamer shackled to low compression heads and restrictive exhaust systems, a technological showpiece deployed into a market that was rapidly deciding it valued fuel economy over horsepower. Ford gave it 5 years. In those 5 years, it powered the fastest Boss Mustang ever built, the most exotic car Ford ever sold through its dealer network, and the most legendary sedan in Australian motorsport history. And then it was gone. And there you have it, the 351 Cleveland. An engine that proved the best engineering in the world can't save you from bad timing, corporate cost-cutting, and the federal government. If you've wrenched on one of these, owned one, or spent way too much money chasing Cleveland parts at a swap meet, I want to hear about it. Drop it in the comments. And if you made it this far, subscribe. We do this every week.